Hello, my name is Lucas Guffey, and the following is my presentation for CIS 4600 to accompany my final paper. My project is on malware and the obfuscation of malware. I became interested in malware while learning about two different NICE framework job roles, the cyber instructor as well as the law enforcement um, forensics and counterintelligence job. And both were interesting to me in part because they looked at malware, which is a very present concern for anyone that uses computers, devices, and the internet. So I wanted to dive into that and learn more about it. So what is malware? Malware is malicious software that is designed to have an unintended effect for the user that is malicious. So there's a variety of different types I go into more in the paper as far as their characteristics, but viruses, worms, trojans, bots, spyware, and adware are all examples of malware. They are used by criminal organizations, they are used by activists, they are used by individuals. There is a lot of malware out there that people can learn about and use. So it's not something that you have to be an expert in to try, which is why protecting yourself against it is so important. So when we talk about malware, there are two main purposes that we see malware used for. There is the profit reason. We hear often about account information being stolen and then identity theft occurring as a result. We hear about bot networks where criminals use other people's computing power to commit crimes for profit. We also hear about malware being used for disruption. So you hear about denial of service attacks, maybe against a website where an activist doesn't agree with the views, or you hear about a public figure clicking into an email link and having their private life exposed because they clicked onto a link that had a file with a hidden piece of malware that executed itself, got downloaded from a website that document connected to, and now all of a sudden you have a malicious piece of programming on your device. So that is obviously very disruptive to someone's life. Nation states also use malware against one another for disruption as well. So what is obfuscation then? If you are a malware author, you want to hide your malware payload. You want to make sure that scanners, that network firewalls cannot detect your malware. You want to make sure that if it is detected or found, that it is difficult to figure out what your malware is supposed to do. And that is where the exclusive OR operator obfuscation comes in, which is what I want to present on a little bit, is how to crack that type of camouflage on a malware piece of software. So I'm going to switch now to my virtual machine to show that off a little bit. So the tool I'm going to use is BowBuzzard. It is a Python program, and what it does is you can put in a file or a section of a file, or you can put in a program or a section of a program, and it will run through its library a variety of exclusive OR combinations that malware programmers use to hide their programming on a bit and byte level. So the tool we're going to use within BowBuzzard is BBCrack. And the reason that exclusive OR is important to know about is that it is one of the most common methods of hiding malware on a binary level, and it's easy to combine with other operators to hide your code. So I'm going to click briefly into the transforms, which are essentially the keys that this program uses. But we have, the exclusive OR, then accompanied with an incrementing second layer of encryption. Or we can see the exclusive OR, then accompanied with a rotating scheme. So it's so prevalent in a variety of schemes. My paper outlines it not only being used in documents, but also used to hide malicious websites or kind of dummy login sites. So it's used often. So we are going to go ahead and show how this tool works that can let us read a camouflaged malware file. So what we're going to do is go to the command line, which is what we run BBCrack from. And I'm going to go ahead and open my BowBuzzard folder to get to the script for BBCrack. And I like to just slide it in to make sure I don't make any mistakes. In syntax, I'm going to let it know that I want it to search against all of its keys. And then I am going to go ahead and grab from the maker here one of their sample documents. I used some malware from I guess the best way to put it is a repository website called Contagion, and had some luck using it, but I wasn't getting the results I wanted. So I'm going to use the sample here for this presentation. And I will go ahead and run this. Open this up so it's a little easier to see. And what it's doing is running through that file, and any sections that BowBuzzard in its library identifies as being suspicious, maybe spaces where there shouldn't be, or what looks like maybe the pattern for a website that could be used to download a damaging piece of malware. It's going to then run these keys against those sections using BBCrack. So this takes a little while to do, depending on the size of the file. And what it will eventually do is assign a score to the key that was most effective and make a file that we can examine. So I'm going to minimize this and go to the score for sample 2, which I used. And we can see for sample 2, it identified the most likely encryption as an exclusive OR of parameter 67, and then a rotate left of 3 bits there. So what it's essentially doing is taking 2 passes using 2 different operators, an exclusive OR, and then a rotate to hide this code. Now I'm going to go to a hex viewer. This is File Insight, and look at sample 2. And I've highlighted what got decoded, which is essentially a little description of what could have happened with a malicious document that you may have opened in an email from a phishing scam, where once the file was opened, it has instructions to contact this website and then to download this executable file and then run it. So maybe that downloads a bot onto your computer, maybe that downloads a virus, maybe that uploads something from your computer. Malware is very flexible, and it's only limited by the imagination of the writer. So it's very formidable. So that's the part of my paper I wanted to present on. Thank you so much, Professor Henderson, for your time and your help this semester. I really appreciate it. Have a great day.